In the U.S., the monetary cost of product damages is upwards of $15 billion. It's on average 1% of overall sales, or typically we see it as being about 10 times as much as a customer will spend in stretch film in a year.
We know all the physics about it. We just have to apply the physics to the load, test it, and measure how much movement or displacement that we have.
Our process follows 5 steps that we call synergy solutions, which is much like a Six Sigma DMAIC process that's specialized for stretch wrapping and stability projects. The first step in the process is to evaluate. We evaluate the project goals and challenges, the environment we're working in, and the tools we have at our disposal to attack the problem. This almost always means testing the stretch film, and for stability projects, we'll test the unoptimized load as well. Stretch film is involved in nearly every project we take on with customers, and its properties form the building blocks for how we address stability issues. The primary properties tested for stretch film are ultimate stretch at break, cling, puncture resistance, tear resistance, hole propagation, consistency, and stiffness in the machine direction and transverse direction. These last two are particularly important because it's the film's stiffness and resistance to stretch that prevents layers of product from sliding and causing the load to be unstable. Until recently, only machine direction stiffness could be measured properly at real-world wrapping levels and tensions. HiLIFE's new TS Revolution film test system makes testing transverse direction stiffness at real-world levels possible as well. We evaluate the load stability using HiLIFE's transportation simulation system, which applies acceleration and vibration simultaneously to test pallets against the stresses in truckload shipment. Acceleration is achieved by tilting the load, which creates forward acceleration that we can hold for any amount of time. We use our understanding of the problem and the tools at our disposal to create a solution. A new wrap pattern that we expect will improve load stability, which is then tested for effectiveness on the transportation simulation system. Any lingering issues are observed, addressed, retested, and so on until an efficient solution is found. Once we have a solution in the lab, it's time to reproduce those results in the field on the customer's packaging lines. We schedule time at each customer location, set up their wrappers to achieve the lab results in the field, and implement a system to maintain those results. Maintaining results means monitoring the loads as they're wrapped each day. The most effective method to maintain wrap quality is to continuously monitor each load as it's wrapped using HiLIFE's HiLIFE monitoring system. HiLIFE connects any stretch wrapper, new or old, to the internet and collects performance data on every pallet that's wrapped. We can train these monitoring systems what a good load is and what a bad load is so that we can track proper wrapping and receive real-time alerts when something's gone wrong, so that it can be addressed before there are problems on the road.
There's so much effort that goes into a product prior to it being wrapped and packaged, so much quality control on the front end. Very few people put that much effort into it on the back end. And it being produced and packed, that's the most expensive time to lose it.
It's fun to have customers in, bring their loads in, test their loads, and see what the existing standard is, and then improve upon it and be able to show them definite engineering results with data. With the data, we can show them the actual beginning and the end.
And so it's really important to have standards that are tested and standards that you can rely on.